We know a lot of things already, but one of the last major things we have to go through are the connections. So we know how to create members, we know how to create plates, but how do you put these together? How do you bolt things? How do you weld things? How do you connect things to each other? First of all, I quickly have to mention that every time we created a component, didn't matter what it was. Let's take, for example, the properties of this column. It's a column, certain size, certain steel grade, certain properties, but I've created everything as main members right now. The concept of main member and secondary member has more to do with the assemblies. Afterwards, an assembly typically has one main component and all the attached components will be secondary components. In some software, you might have to choose yourself what is main, what is secondary. Over here, I don't care. I don't have to think about these kind of things. I just create everything as main. It doesn't matter. The software afterwards will determine what component will be the leading component, or let's say the main member, and what will be the secondary member attached to it. There are only very few rare cases, in the cases of joists perhaps, or staircase stringers, where we would like to force these kind of things. But generally speaking, we don't have to pay too much attention to it. I quickly had to mention that before we look at the connections. Let's first of all switch maybe to the ground level, and let's add some of the plates we saw earlier. A square plate, for example. Not a grating, but a standard plate. Just give it a certain thickness. That's fine. It's just to have a plate. I forgot the offset apparently. There's still an offset in this box. There we go. One over there later as well, and over here. So if I were to create any holes or anchors into this base plate, I might need a couple of coordinates first. Coordinates that could be used through points or placed through points. Add is a typical one, where I would say we're going 3 inches one way, from there -6. So 3 inches one way, -6. Copy that value in Y, and from center, we're indeed then going in all directions. So at least then I have a couple of references to create a connection. And let's then start with holes. Right mouse click. The idea is to have a standard hole with designation D. That's just a standard hole, but we can also pick other types of holes, but generally it's just a D. Diameter, just enter whatever diameter you need, is the field hole or shop hole. Most of the time these are shop holes. We're not going to link it to a stud or an anchor. Just say OK. 1, 2, 3, 4 locations, enter into which component, this component, enter. That plate also can be welded. We have automatic weld or manual weld. Most of the time we'll use automatic weld. Right mouse click to call up the setting box again. We're going to use American Standard. What kind of weld? We can click on the image to see the various types of welds. For example, fillet. The next icon on the right is what kind of finish we would like to it, and depending on the finish, you might have other values to enter in some cases. This could be a shop or field weld, could be all round or not. It could be that we just have an all-round weld, or we say no, we have different types of situations. Double-sided weld, near side, far side different, web and flange different, but let's keep it simple for now. And just say OK. First member to connect, enter second member to connect, enter. And it basically just connects the two components. It also doesn't matter so much anyway. It doesn't have any effect on the output, on the assemblies, on the symbol, in which direction we pick. It just knows that member 1 is connected to member 2. That's all we care about. If you have a look in some of the other settings, we could specify fishtail comments. If, for example, you'd say typical. If you want to go into weld marking, you could do so. If you want to reverse the symbol, you could do that as well. And if you want to specify information, NDT, and other inspection information, or add free attributes, you can still do so. But in general, 99% of the users out there will just use whatever is available in here. It also doesn't matter in which view you are, of course, member 1, member 2, and it is connected. Just as a little detail, you can run a clash check if you want. So figure out if these two are clashing or not. And I can see, for example, that these two are clashing. Indeed, the beam is not adapted to the column yet. So sometimes it can be a useful little piece of information to see if something is clashing with something else when we connect it or not. If I want to create some bolts, no problem. There's various ways to deal with this. Let's just quickly make a plate on that beam. So plate PL 10 1/2 inch. I'm taking it from the side like this, and we'll just go from, so create that plate 1, 2, and then make sure that they're adapted. Length modification, adapt to member, no clearance. And this adjusts this. And just to make my life a little easier, I'll just put in 2 intermediate. I won't bother with any distances right now. I'll keep that for the exercise later. Now, connection, bolts. I can choose whatever bolt or anchor I need just from the catalog, or I can load a specific configuration to what we can call these keys. So if I choose a specific key, say this one, and I click on this icon, it will load its configuration. This can be a field bolt, it can be a shop bolt, could be a field bolt with field hole, shortest grip length, or through hollow sections. All these things can be determined here. We can also specify if we want a second hole, if we also want a slot hole. Perhaps it will be easier to see it like this in 3D. So if there's a slot hole required, we could immediately add one with the bolt. Now, one thing you must know is that we always create a hole with a bolt. It always comes with a hole, as we can see here, unless we specify otherwise. So if there's already a hole available, or if it's a self-tapping screw, for example, we're dealing with, or even a nail for that matter, we could just use this option to say, no, we don't need any. But generally, if it's a self-tapping screw, this kind of information is already added in the database with that component, and it would be set by default for that specific component. You would not have to change it manually. Then we'd go OK, 1, 2, enter. What members do we want to connect? We want to connect these two, and I'm getting a message. That simply doesn't work. A message on the side that would simply not work. Why not? What's wrong? The idea of creating bolts is just like the holes. We're creating them in front view. So we're looking at the head of the bolt, not the side view as what we're having here. We're basically looking at it like this from top. So if I want a bolt to create a bolt in side view, we can still do that, but I have to go through the second tab, side view, and specify an offset. So here it says absolute or running dimension, 2 inches in front, 2 inches behind from the axis. So let's see, 1, 2, enter, and these components are to be connected. And there go the bolts. So I can see them up there as well. Very exaggerated as a situation, but it serves as a little example at this stage. If I, for example, go back to the anchor plan or to level 0, I already have some holes here. Let's get rid of them. Connection, delete. There, they're gone. Go back to connection bolts. Because bolts will also, I switch off the side view, will also allow you to create anchors. Say if I go here, for example, and I say I want some anchors. So I just pick a random anchor, doesn't matter what it is. The idea being that I can pick, okay, 1, 2, 3, 4 locations, enter, pick a plate, and nothing happens. Even I confirm with enter, nothing happens. What to do then? Right mouse click. There's an option. Allow loose bolt. So by default, the software expects at least 2 members to be connected. But if I want a single component only, I have to switch this option on. And it says, for example, for anchors. 1, 2, 3, 4 locations, enter, into that plate, anchor, enter. And then the anchors will be placed into the base plate. And that's it for now. For the connections, there will be more functions to discover, but that will come at a later stage.